Alright guys, last one. Thanks for hanging in there with me. I know today's kind of a long one, but hopefully it was fun with all the demonstrations and stuff. We're moving on to our last one. So these all are going to relate to each other a little bit like our ones before have. And again, we have our hydrogen bonding picture up here to help us explain these concepts. So the first one is this penny drop. So in this experiment, you had your penny, you put drops of water on top of it, and you saw that it kind of really formed this bubble. You were able to put around 30 drops of water, about 30. I can't remember in the video how many I got to, but it's about 30 drops. And so we need to talk about why were so many of those drops able to stick to our penny, fit on our penny. And so I use the word stick. And so water has two different properties. It is able to stick well with itself and stick well in other things. And again, this is because of our hydrogen bonding. You'll notice that hydrogen bond between that O and H makes water very sticky. And so, as the water goes on the penny, it sticks not only to the penny, but then also to itself. That's why it starts creating that bubble. Because the water is all sticking to itself. It's hydrogen bonding. It doesn't want to fall off. The gravity's pulling it, and eventually the water is going to get bubble so high that the bonds aren't going to be able to hold it anymore, and gravity will pull all the water off. But at first, those hydrogen bonds are able to kind of fight gravity off and keep the water together. And so it's because of the hydrogen bonding, it causes water to be sticky and stick to itself. So this is called cohesion. You'll hear that word sometimes, cohesion, adhesion. You don't really need to know them for this class. It might be good to use on a test or something like that, but cohesion is when it sticks to itself. All right, this next one was, we had a cup. It was filled with water, and when you put a paper clip on it, it floated on the water, even though it should sink. And so, why did it float? That's our question. So I'm going to draw a picture right here, and I'm going to draw what the surface of the water looks like. Oh, shoot. Here we go. All right, so we have, these are just going to be water molecules. Okay, all these water molecules on the surface of our water are all attracted to each other. So all of these ones are attracted to each other, like this. They're all attracted to each other. And because they're attracted, they're forming this very tight surface. It's called surface tension. And because of the surface tension, if you place something kind of balancing on the water, like that paper clip balancing the right way on the water, it will actually hold it up because of surface tension. Because the water is attracted to itself and is making that surface have a little bit of tension in it, it causes the paper clip to float. So the cohesion, or the sticking out together of water, so cohesion, because of hydrogen bonding, leads to surface tension, and that surface tension holds up the paper clip. This is also why, if you've ever seen those bugs and they can kind of like float on the water, they are floating because of that surface tension. That's why they're able to float on the water, because of the surface tension. That's caused because of the hydrogen bond between these molecules is causing it to be really tight on the top and have that tension. All right, this last video was super cool. It was this balloon that we had, right? And then they popped it. And then what happened is the balloon popped out. And then it had this water that still was kind of in a shape of a balloon for a second. So I was talking about, why was the water still in that shape of the balloon? So again, we're going to talk about that word cohesion and about water sticking to itself. And because it's sticking to itself, this O and H are attracted to this O, and attracted to this O. And so because of this sticking together, kind of creating these bonds that are really stuck together, it will hold its shape. And then eventually gravity will pull it down and it, splatters everywhere. But for the most part, it's going to hold that shape and be sticking together for a split second while it's still in that shape of that water. And so that's why we see it stay in that shape for a little bit, because it's sticking together. It's good to ask your question sometimes, like with, if we put some other substance in a balloon, some other liquid, would it stick like water does as well? And your answer is probably no, right? Because water has a special property of hydrogen bonding that's causing it to stick. So for all of these different ones, if we did like different drops on a penny with a different liquid, it probably wouldn't stick. You'd get less drops than 30. So same thing, like you probably couldn't balance a paperclip on a water with some other kind of a liquid because it doesn't have the cohesion that happens in the surface tension that happens because of water, that water has. So our last real world example is plants. So we see that plants are able to fight against gravity and take water all the way up to all of their different leaves, right? You have a tree, and water is able to travel up the tree to all of the leaves. And that shouldn't make sense with gravity. Gravity should be pulling that water down. And so what happens is the water, there's a word called adhesion, where water is actually able to stick to other things. And so because water is able to stick to other things, it causes the water to kind of climb up the tree. So water is climbing up the tree, and also because of cohesion, the water sticking to itself, it is able to carry up a ton of water to all of the different leaves. So adhesion causes cohesion when water is sticking to itself and to other things. That is what's causing that water to travel up. And be able to bring water to the rest of the plant. So with all of these different demonstrations in this one, our main takeaway was that water sticks to itself and can stick to other things because of the hydrogen bonding. So because H bonding, oops. It's really interesting too. You can see this if you have like maybe water in a cup and you had something else in there and you try to dump out something else. Sometimes it kind of sticks to the side of your cup, and that's because of this adhesion and cohesion. So you can see it in lots of different areas in your life. Anyways, these are just some examples. Hopefully now around, just your world, you'll be able to see the cool properties of water. You'll be able to know because of this hydrogen bonding, that is why water is able to act the way that it does. And now if I asked you a question about some other phenomena that we see in our world, some other cool thing that happens in our world, you'd be able to think about hydrogen bonding, thinking about that partial charges and them water kind of sticking together and why water is acting the way that it acts. I know it was a little long today. Thanks for hanging in there. Good luck finishing your worksheet. Please let me know if you have any questions, and I'm so excited to have another term with all of you.